What you looking at?
Oh, it's me, Monaco.
And Milks.
Here with you.
New unit.
New unit, new quarter, new semester.
Ooh, new semester.
Yeah, spring semester starts right now.
Here we go. Let's get on to it.
Solutions. We are going to hit up solutions, themes of central questions, targets, assignments. You know the deal. First video.
Yeah,
This is
don't
what's
skip
up.
this.
This is what's up.
Please engage with this piece, guys, because you need to know why some materials dissolve in water and some don't.
Why? We'll see.
We will.
Why do ionic compounds allow water to conduct electricity? Remember my chemistry in class, that light bulb, you dipped it down in and the ionic ones lit the water
Yeah,
up?
we did the lab, right?
Why?
Yeah, we did a lab in my room about that.
Why?
Yeah, why does like dissolve like? Why is that a rule?
Right, everybody says it, but what the heck does it mean?
Yeah, we gotta figure that out.
How does a temperature change affect the solvent change, solubility?
There you go. Now we're talking reference tables,
Right,
charts.
for
Like,
sure.
We got some real numbers there that'll help us out.
How do you quantify
Yeah, let's put some
solubility,
numbers.
diluted and concentrated?
Yeah, let's put some numbers in there. We're going to actually go back to moles and stoic and put moles in a new light.
Concentration. Two
So
sets of equations. We'll
It's
hit them
not
up.
just a think, by the way.
Gotta do.
What happens to what the properties of water if I add something to it?
Specifically,
sounds like to me.
How come when I add salt to the ice on my sidewalk, the ice melts? Why?
Right.
Why?
It sounds to me like you're all wishing for snow so we can make the ice cream lab go better.
I am.
Like seriously.
Yeah. So here's your targets. I want you to be able to say that I can do the following things, like identify the solute and solvent when a homogeneous solution is created. I
Right.
give you a word problem. Tell me which one's the solute, which one's the solvent. You got to be able to break it down. And say,
Yeah, the vocab words that we gotta know. You can determine which components or compounds will dissolve in water and which ones won't.
Table F.
Might be the hardest table to figure out because it doesn't show you there how in the table how to read it. But when you learn, you'll figure it out. It's easy.
We'll teach you. It's pretty simple.
Not bad.
Tell if a solute will dissolve or dissociate when placed in water. So back to chemical bonding. Is it
Yep.
ionic or covalent? Is it going to dissolve or dissociate?
Polar,
Polar or
non-polar.
non-polar. Yeah.
Use the nature of solute, polar or non-polar, ionic, etc., to determine if it'll dissolve in a particular solvent. Like dissolves like.
So you got the solute, you got the solvent. Will they dissolve? Yes or no?
Yes. We would find
State relationships. Relationship statements are super important about the factors that affect solubility and solutes in water. So like as the temperature changes, the solubility of the solid will do this. As the
Right.
temperature changes, the solubility of the gas will do that.
And notice he did the as thing. So he's talking about one thing changing and it affecting another. That's what we mean about relationships. Not just, there is a relationship between temperature and
Duh.
solubility. Right. What is it?
Thank you. When
Seriously.
we say we want a relationship, you say this does a this and that
Right.
does a that.
All right, so we got to be able to use table F to predict solubility. We just showed you table F, so we're going to you need to be able to use it properly.
Got stuff. What else we got here? We got lots of I cans for this unit.
Yeah.
Use table G. What up, G? To classify solutions as saturated, unsaturated, or supersaturated, given amounts and temperatures.
Yeah, when you guys see supersaturated solutions, they're mad wavy. You're going to love them.
Yeah, super like them.
Table G to find changes in the amounts. So if I have a solution that is saturated and I change the temperature,
Like riding a curve.
then it's going to change how much I could put in or how much more it'll hold.
This graph is actually 10 in 1, so that's
It's-
why we have to teach you how to use the chart.
Yeah, there's a lot going on.
Calculate concentration in molarity, parts per million, percent. Okay. Again, concentration calculations, parts per million and molarity are there.
Right.
And it doesn't say percent by mass, but it says percent composition right here. So there's really 3 equations for
Yeah.
concentration that we'll use.
Right, and molarity is the big one.
Mhm.
That's the one that's the most important. Compare the concentration of solutions, dilute versus concentrated. I like to use the Kool-Aid analogy for this one. If you're going to make Kool-Aid and you want 2 cups of sugar in it versus 1 cup of sugar in it, one's going to be more concentrated, one's going to be more
I
dilute.
thought you would have went with coffee here because you would like strong coffee that's more
True,
concentrated.
but
I like weaker coffee, it's more dilute.
true that could be true, but I don't know how much they care about coffee.
No.
I think they like Kool-Aid better.
Yeah.
I think they know what Kool-Aid is, anyways.
Either way, concentrated versus dilute is pretty simple. Can you predict how adding solute to water will change the properties like boiling point and melting point? We alluded to one with the ice and the
And that
salt,
one's really important.
but this is like the last point of the unit.
Sure.
What the heck happens to the properties of the water when I put the solute into it.
Right. And when we try to hammer this video home, I'm going to make sure we hammer out that they both happen at the same time. The boiling point and the melting point change at the same time. I can just only be at one point at one time.
Yeah.
So we can actually teach you how to cook pasta faster because that's boiling, or we can teach you how to keep from slipping on the sidewalk because we can lower the freezing point of water.
Mm-hmm.
One or the other, but right? It's still
For sure.
water.
Absolutely. So anything else we got here? Oh, unit assignments.
Yes.
Thank you to all my students who started using this properly and using it as a checklist. You know, I didn't put this here for me. It's there for you.
Yes.
Do
Please.
it, follow in order, and you will be more successful. I saw it last unit in those grades,
Yep.
and you're seeing it every unit in your grades.
Yep.
So
But it's the whole independent learning piece that we're all still on the spectrum of getting a handle of.
right.
Some of us are really, really running with it, and some of us are still kind of,
Waiting for Mr. Monaco just to do it for you.
or right. And so
Not gonna
not anymore. And as a matter of fact, collectively, second semester, pulling back. I mean, you guys, come on, stand up. You can do it. I promise.
You can. It's just will you?
Find out
Mm-hmm.
on the test.
Yeah.
Let's do it. See.
So there it is. I think there's one more slide.
No,
No,
more
that's
slides.
it. No more slides. End of video one.
Bye-bye.
Bye. Where's my mouse? Mousy button. Mouse button.